Yeah, I flew in about 2 hours ago, I think I landed. So half my brain's in San Francisco. Yeah, but I'm very excited to be here. This is awesome. This makes all the continents that I've now been to except for Antarctica, and I don't like the cold, so probably it's not going to happen. But my talk today, have you guys read Neil Stephenson books? Neil Stephenson? All right, he has this amazing book called A Young Lady's Illustrated Primer to, it's called The Diamond Age, and it's one of my favorite books, and I love it. Usually my talks feature lots of My Little Ponies, but we kind of went Victorian this time because I love that book so much. For those of you who don't know me, my name is Charity. Our book, Lane and I wrote this book about database reliability engineering, and it came out the day before I left. I have one at home. It's so cool. Never write a book, it's terrible. Also never start a company, also terrible. Or run a conference, excellent point. All of these things are terrible. My background is firmly that of, it really doesn't like when I go over there do it, is operations engineering, which is why I believe that the only good diff is a red diff. I will write code when I have to, but I really believe that code causes problems, and I don't like problems. So the less code, the better. I didn't hear that. Anyway, the story that I'm referring to is a cyberpunk story, and it's about the future, when our bodies and the world are teeming with nanotechnology, little nanites, tiny little robots, and all their buggy little software. And it reminds me of the famous quote that says that software is eating the world. And as I will tell you, also probably our brains. Isn't that terrifying to think of continuous integration all the way into your cerebral cortex? So in preparation for that day, let's talk about technical judgment, making good choices with software, and survival. Technical judgment is a thing that we do every day. I don't care where you are in the org chart or the software lifecycle, whether it's greenfield or brownfield, we're all kind of continuously threading the needle between innovation and stability. Making things better for our users, making things not too much worse for us. It's more important than ever, but it's also getting harder and more complicated very quickly. To prove it, I did some science, and I produced an extremely sciencey graph for you. By my precise calculations, making good choices is going to be impossible in about a year. I don't know. But you can tell it's true because I have a graph. How did we get here? Well, 15 years ago or so, we had the LAMP stack, right? I started computering when I was 17, dropped out of college. And I remember these choices were hard. We had to choose between MySQL and Postgres. Right? Nginx or Apache. God, and the P went from PHP and Perl, Python, that was tough. Who here remembers CGI bins? May they rest in peace. Good times. And then around 10 years ago, we're like, this sucks so bad. This is not maintainable. 10 years ago, much longer than that, we started unpacking all the monoliths, right? This is around the time that I was at Linden Lab making Second Life. And we were just spinning off tables, put them in their own clusters, sharding, REST APIs, more loosely coupled services, right? Microservices before they were microservices. We got rid of maintenance windows, unless you're a bank. Am I talking too fast? Can you guys understand me? Okay, cool. All this seems completely basic to us now, but I think it's important to remember that at the time, it was terrifying. And it was not obvious that it was the right solution. It was a really challenging transition to a new way of thinking about infrastructure and software. But we did it to increase resiliency, and honestly, we did it for the same reason that everyone makes a change. We had no other choice. Doom was on the horizon. So we get through it, whatever. Config management, okay, so the last time I was building a new infrastructure was Parse. Mobile backend as a service, the job that I had that got acquired by Facebook, and then I did Honeycomb. But when I went to like make choices how to build parse, I do feel like there was a good cookbook for me to choose from, right? Am I going to use Chef or Puppet? Well, that was a choice, but I didn't have to decide whether or not to use config management, right? Like all these things like virtualization, continuous delivery, all these things went from cutting edge to table stakes. And there was a brief period of calm, I feel like, after everyone got used to AWS and before this hit. Like, when I went to build Honeycomb, I started from scratch. Like, I've never done a greenfield infrastructure project before. Like, I don't do that. I don't do greenfield. I come in when your field is sort of working and shitty, and I make it work. That's what I do. I feel like I'm pretty good at this shit. I do. And yet, when I sat down to build Honeycomb, I went, where to start? You know, containers, are they ready yet? Like, do I use a scheduler? Is that prematurely optimizing? Like, there's all these databases. Like, it was genuinely kind of staggering to me. Where do you start? So, out of all this chaos, this is basically what the talk is about. Like, out of all this chaos and out of everybody who's trying to sell you things, right? And I'm a vendor. Like, you should never trust a vendor. Like, they're innately unreliable because they have a mission of their own. I have a mission of my own. Don't trust anything I say. But there are patterns that we should be paying attention to, and that's what I want to talk about. Like, these are the themes. Polyglot storage is now something that everyone has to do. Remember when there was the database? The database. And it was not a good practice to have anything more than one, right? You pick your poison and you drink it every goddamn day. Well, okay, storage technology has come a long way. There's a lot of competitive advantage that you can now have by using some of the newer data storage types, like fucking graph databases, you know? Like, the way that you succeed as a startup is by taking more risks. And there's a lot of good risks that can be taken with data. That is a sentence that should never be spoken. Whatever. Composable infrastructure, right? Outsourcing large components of your deploy pipeline or your tool set to other companies. It's real now. It's containers growing up, kind of. Like, we're gluing together more third-party platforms before, more types of software before, and yet our in-house engineering cycles are getting ever more constrained. So what all of these trends have in common is that they increase a certain kinds of complexity, which is why the following is also true. Like, well, monitoring, not enough. Having a way that your system should look, writing checks for that, and then just like walking away and trusting that it's true, not good enough. Operational skills are now table stakes for all engineers. I actually think this is a really exciting time to be in tech. The open source world, the small companies, we're increasingly getting access to the kinds of tools that Google and Facebook have had for a long time, which is because we now have the problems that Google and Facebook have had for a long time. And like that delta of that window of time between when the big companies get a problem and when the rest of us get a problem is shrinking, but it's cool, right? And you might think, oh, more choices are great. And it will be, and sometimes it is. Like, this explosion has so much pent-up creativity and energy and exciting new ways of like modeling data and interacting with services. Eventually, a lot of stuff's going to mature. The weak will die, and all of this will be boring. But in the meantime, this is actually really, really, really hard on humans, right? It can be cognitively overwhelming. The choices that you make now, you will not know whether they were good or bad for a long time, potentially. There are not a lot of established best practices, or you could say that there are too many established best practices. Every time somebody writes a blog post about their stack, you're like, oh, that sounds great. Well, then you take them out for drinks, and they're like, this is the worst. It's like, I don't know, glass half empty, glass half full. Many communities are very immature. There are very few reliable narrators. Everybody's trying to sell you something so that you can make it battle-hardened. So does this mean that you shouldn't use any of it? Absolutely not. But it means that we need to think carefully about our tolerance for risk as an organization and where to spend it. The answer is not take no risks or you'll go out of business. The answer is not take all the risks. there are a few tips that I have for making good choices, and most of it, honestly, if you think about it, it boils down to where do you wisely spend your risk budget to have maximum impact. And I feel like these are the kinds of principles that really good senior engineers have internalized as gut reactions. You know, they can't always unpack it and explain to you why they viscerally recoil when you bring up MongoDB in 2013. But I think of intuition as like the accumulation of scars. I don't know, I'm a pessimist. But let's start with the prime directive. And this applies to all of us, so let's ask Captain Picard. Your technology exists to serve your mission. What's your mission? I don't know. Maybe it's getting people health care. Maybe your mission is making the world more open and connected. Any Facebook people here? Probably not. Good. Or empowering developers to make mobile apps. Building software is not your mission. Even if your mission is literally writing a database, building software is not your mission. And we all love tech so much that it's easy to lose sight of this. But like, building software is just a layer of abstraction. If you're writing a database, your business is empowering your customers to do better things with their data, right? In fact, I think it's more helpful to think of software as the enemy. Every piece of software that you add to your stack adds more fragility and more potential points of failure. Every piece of software that you write yourself is something that other people will be debugging and maintaining for years, and that's the best case outcome. Code is liability. The best code is no code. The second best code is code that someone else wrote and maintains and has to worry about, but you get to use, lots of other people use. But you can still read and understand for yourself in a pinch. The worst code is literally anything else. It's easy to lose sight of this, but as a technical leader, it's your responsibility to make sure that decisions are made to serve the mission. I don't care how much somebody loves Red Hat. If you're already running Debian, that's what you're using. You do not run both. I don't care how much you have somebody on your team who really wants to write a hardware crypto device for your cage. They're not doing that unless that's literally your mission. Write as little software as possible and resist this software sprawl, which is just reuse components and solutions wherever possible. This especially applies to storage systems. Like, the closer you get to the data layer, the heavier price you pay when supporting an additional component. Jessitron has this great blog post out there. Have you guys read the blog post by Mick Funley about choose boring technology? Oh, I love that post. I think I have a link in here later. But it's like, he's like, look, assuming if you're a startup, you have 3 innovation tokens. That's where you get to spend your risk. You want to spend them, but like, spend as few as possible. He wrote it while he was at Stripe. Stripe was notorious for years for just having no discipline around adding shit to their stack. It was a nightmare. Hopefully no Stripe people here either. Anyway, so I love that framework. I love thinking about that. Like at Parse, we were clearly choosing MongoDB as one of our innovation tokens, right? We ran over 1 million mobile apps on MongoDB. We helped MongoDB grow up. When I was at Facebook, we partnered with them to get the pluggable storage engine API. I believe the best thing that ever happened to MongoDB was Facebook acquiring Parse. But like, that was it. We put all 3 of our innovation tokens down on that motherfucker. Everything else was as vanilla as you can get. Later on, we spent an innovation token on Golang when we did our rewrite. Everything else was as simple as we could make it. For any storage component that you have in your stack, you need to monitor it, graph it, have people on call for it who know how to debug it, upgrade it, load test it, maintain client compatibility with it, debug it, write libraries for it, scale it, deal with migrations and botched migrations and transformations, and like, it's expensive. And another way of putting the same thing is, as Dan McKinley says, optimize globally, not locally. If you pick the perfect solution for every local problem, you end up globally with an incomprehensible nightmare and engineers who can't move around and solve anything other than their corner. Now, if you're a baby startup, some chaos is fine, right? You should be optimizing for experimentation and velocity, because most startups fail, and not because they moved too fast. It's because they didn't react enough and they didn't respond quickly enough. But when your time horizon gets longer, when you plan on being around for a while, you all need to shift your focus to maintainability. And the first step to doing that is having some gating process for major components, like a new language or a new database, a new hosting provider. Like, it shouldn't be impossible, but it should have enough friction to make it intentional. The point of adding friction is to make people stop and ask themselves questions like, can this be solved using something we already support? Or like, what is the relative gain of the new technology? Like I said, if you have Ubuntu and someone wants to add Red Hat, no. Fuck you, no. But if you have concurrency issues and you're using Ruby and you want to switch to Go, that might be a lot of pain, but it might be worth it. But if somebody is using Ruby and wants to switch to Python because they know it better, no, probably not. The relative gain is not large, almost always. I think that as leaders and managers, it's important to let people have fun and try new things. You don't want to shut everything down, but know your critical path, right? Know your critical path. Keep it as small as possible. Jessica Tran's blog post that I was mentioning, she talks about where your risk appetite should get spent. And basically, it's this rainbow continuum where developer tools, yeah, whatever, let the kids play, you know, let them like do shit in their sandboxes. And like it gets to the application layer, the critical path of the application layer, and then databases. Databases are red. There is this awesome blog post written a couple years ago by somebody who was upgrading MongoDB, a particular version, and they just they upgraded one node, went, oh, this looks cool, upgraded the rest of the replica set, had a problem, and I'm just like, and they start bitching about MongoDB, and I'm like, excuse me, you did not leave a single node running with your stable version for more than a day? No, you deserved that. I hope it hurt a lot. Choose boring technology. Oh, I forgot I had a slide for this. Right. What boring means, boring does not mean bad. Boring software runs the world. Boring just means that its failure modes are well understood, and that the ecosystem is rich and mature. For a language, it means rich library support. For databases, it means lots of other people run it in production and will stress test it for you. Boring means that there is a wide user base. Boring means you can Google the error code and find it on Google. Use it. Use it when you can. If you have somebody who wants to rewrite cron, stare at them with judgment. But the corollary is that you should spend it. Google has they have they're super addicted to nines, like 5 nines, whatever. But they insist that you actually spend your risk budget. If you're getting to the end of the window and you haven't spent your risk budget, they're like, go, try something new. What have you been wanting to do for a while? And I think that's awesome. I think it's awesome because failure shouldn't be rare. Well, first of all, it's not going to be rare. Failure isn't rare. So you should make it common. You should make it boring. You should make it something that people don't panic and freeze up when it happens, right? You need to have dress rehearsals. If it happens often, you will learn lots of things about making things fail in ways that your users will never notice, right? This is why I love testing in production. Seriously. I hate that meme. Well, actually, I love that meme. The meme is awesome. The meme is dope. Well, it's like, I don't always test, but when I do, I test in production. You know that one? I love that meme. I also hate that meme. But like, test in production does not mean don't test before production, right? You can do both. You can do all your unit tests and integration tests. Whenever something is a known unknown, you should write a test for it. And you should also be comfortable with the fact that there are lots of unknown unknowns. Like, if all your dashboards are green you're just, you don't have enough visibility. And that's fine. We should be comfortable with this. There are gremlins in our software. It's cool. Low expectations are great. Core differentiators are where you spend your risk. Some good reasons for supporting new components. First and foremost, if it's core to your mission, if you can't be the version of you that you want to be without this component, do it. If you're replacing or upgrading an existing component, that's fine, that's great, but have a timeline and commit to getting rid of it. The last 10 or 20% of the project when it comes to upgrading, say, your operating system or your database fleet or something, you know how that last 10 or 20% tends to grow into like 200% of the time of the rest of the migration? That's a really bad habit that we all kind of have, and we need to kick it, because it exacts a real tax on your team. It's always unintentional. It's always just that one or two edge cases that are just so challenging, but it's worth committing to. It's totally legitimate to give preference to software when you and your team already know how to use it, when you already have local experts. That's worth it. That's a legitimate concern. It's totally legit to use software because the community is better. Back when I was doing Parse, I had only used Puppet. I didn't know Chef. And I decided to use Chef because the community seemed better to me, and so I thought it would probably win. And I feel really good about that choice. Do not choose a new component because Hacker News likes it or doesn't like it. They're always wrong. Or because of vendor benchmarks. Mark Callahan calls it benchmarketing. I love that. Quality communities make software way more likely to succeed because they're welcoming. That shit's going to stick around. And that means it'll improve. Also, a lot of this advice kind of boils down to consider the operational impacts and life cycle of the technical decisions that you make. And the best engineers, the ones that I love to work with, are the ones who do this instinctively. Outsource as many operational problems as you possibly can. That's not your core, that is not the thing that's going to make you unique, that is going to make your product different than everything else. Anything that's not core to the success of your business, try to avoid doing it yourself. Pay someone. Because the problems that are core to your business, your core differentiators, you always are going to need to keep them in-house. So save your precious and scarce engineering cycles for those. Culture can do a lot of heavy lifting for you here. If you celebrate the engineers who remove code, who deprecate features, who simplify, who refactor, who reduce duplication, it's always judgment call, right? It's always context. It's possible to do this too much, but I have seen very few teams that err on that side. And a lot of this is because we don't celebrate it as much. You know, we celebrate shipping new features. Everybody can see them. Woo! The things that you celebrate in your culture are the things that will get repeated. And a lot of this is so subconscious. But I realized this when I realized that I was at a terrible job a few years ago, briefly. Every time that we had to release something, everyone was up all night, you know? The engineers would be up till like 3 a.m., 4 a.m., they're just haggard and tired, dead in the eyes. And the CEO would come in the morning like, yeah, guys, this is so rad, donuts. He'd be like, Tommy, you're the best. Whoa, these guys care so much, they were up all night. Well, guess what? We did it every fucking time because they celebrated it, you know? Even the people who wanted to go home, they were seen as kind of buzzkills, you know? We're in it, this is so great. It's like, no, celebrate not slipping. Celebrate getting to go to sleep. You can acknowledge people and thank them for their heroics privately in ways that acknowledge what they've done, but put the emphasis publicly on, dudes, I'm so sorry this happened. How can we make it so that this doesn't happen the next time? And then when it doesn't happen, praise them for that, right? It's harder because you have to look for the dog that didn't bark, but it's super, super worth doing for technical leaders. And lastly, choose tools that help you ask better questions, not ones that try to provide answers. If you do Twitter, you've probably seen me ranting about dashboards quite a lot. I fucking hate dashboards. And I hate them because they're answers. Every postmortem you've ever been in probably ended with, okay, and how can we create a dashboard so that we find this problem immediately next time, right? And when a problem happens, you're just like, boom, there it is, you know? And then you've been using this software for a few years, and you start to have dashboards to find your dashboards with your dashboards of your dashboards. And when something breaks, when the site goes down, you go look at your dashboards, and everything goes up at once, or everything goes down at once, or like, there's no narrative there. You're not actually doing engineering. You know why the debugger of last resort is always the person who's been there the longest? Because our debugging tools are so bad that we're not debugging so much as we have these answers, and you need this giant submerged like iceberg of intuition to interpret them, to impose a story upon it, to figure out the causality of this happened because of that happened. That's not okay. Like, it's fun to be that person once or twice, to be the hero who, you know, gets called on the beach in Hawaii. Parse is down, it's been down for an hour, we don't know if it's ever coming back up. You're like, all right. You know, it's fun until you've been doing it for a couple of years, and then it's like, this stopped being fun a long time ago. I would like to sleep. I would like to not be necessary. And it's really depressing to be an engineer who joins later, too, because you know that you can never catch up. Because it takes so much intuition and so much like knowledge of how the system is going to behave in order to be able to tell it's happening. And I blame dashboards for that. The approach that we're taking at Honeycomb is more like BI, business intelligence for systems, right? They don't start out by assuming they know the answer. They ask a question and another question. Well, what about this? Well, what if we sort it that way? What if we do this, you know? Sorry, I could rant on about this for a long ass time. But the fact is that we're all distributed systems engineers now, right? And as distributed systems engineers, we need more operational knowledge, and we need tools that don't assume that we know the answers, because there are so many more unknown unknowns out there than there are known unknowns. We also need to get better at building and choosing tools that treat us like human beings. Like, I use Vim too, but like, I love Vim, but it's an abusive partner, like it really is. We should not have to memorize how to use our tools. Nothing like that would ever survive the consumer market. We build tools for engineers as though we're robots. And this is alienating. This is alienating, and it builds silos between teams. Like, tools build silos. When you can't understand the tools that another team uses to interact with the same fucking systems, that's a silo, and you just built it. Anyway, I'm wrapping up. Here's your technical decision-making manifesto. Technology serves the mission. Reuse solutions. Create some friction intentionally for adding new components. Choose boring technology when you can. Spend your risk tokens on your key differentiators. The longer you survive, the more operational impact trumps all, and question everything. I actually think it's funny that I like to tease software engineers sometimes by saying, you know, honestly, if you compare the amount of time that you spend operating software to the time spent developing it, you can round it down to 0. It costs 0 time and energy to develop software. Doesn't even matter. Just like emerges one day, built, and then we run it for 10 years. It's not really true, but it's funny. Most startups fail, but they mostly fail for lack of traction or product market fit, not because you chose the wrong language. This is the dirty little secret. Doesn't really matter. Tech barely matters. It's table stakes, right? It doesn't matter. It matters insofar as it affects our quality of life, right? Facebook was written in fucking PHP. I rest my case. At Honeycomb, we've had lots of new employees comment. They're just like, oh my God, it's so clean and so beautiful. I've never, you know, and we enjoy it. It's really nice to work in clean systems. It's nice. But we don't fool ourselves into thinking that's what will make us succeed, right? It's an aesthetic choice. It's really nice. But what matters is, what can we build that will help you sell this? right? What can we build that will help you connect this to people's real lives and choices and problems? So 15 years ago, somebody was probably giving this exact same presentation, except they were complaining about how now they had to choose between C and C++, and Perl and Python and PHP, Oracle or MySQL, fucking Java. Ugh, too many choices. It's same old story. But the choices you make can have a huge impact on how quickly you can move, how much technical debt you accumulate, and how quickly, and how happy the engineers in your team are, which directly affects your ability to retain and recruit. So, cheer up. Enjoy it while you can, because these are already basically the good old days. Thanks.